Chapter 2. Variables. Exercise 1. Variables. Variables are how we store data in our program. So far, we've been directly printing data by passing it directly to the console.log function. Now, we are going to learn to save the data in variables so we can use and change it before we need to print it. A variable is a name that we define that will point to some data. For example, I could define a new variable called myHeight and set its value to 100. I could also define a variable called myName and set it equal to boot.dev. Let. To create a new variable, we use the let keyword. Let my new variable equal 2. Let this can be called anything equal 3. Assignment. We need to keep track of our hero's health. On the first line of code, create a new variable called player health. Okay, so I'm going to type the name of that variable and set it equal to 100. And following the syntax from here, I have to type let, and I'll type space equal, it's equal to 1000. We can do that. Okay, that's it for that part of the lesson. Run, correct, good job, next. Exercise 2, variables vary. Variables are called variables because they can hold any value, and that value can change. It varies. For example, the following will print 20. Let acceleration equal 10, acceleration equal 20, console.log acceleration. The line acceleration equal 20 reassigns the value of acceleration to 20. It overwrites whatever value was being held in the acceleration variable before. Note that we don't use the keyword let again. That's because let is only used to declare a new variable. If we're just changing the value of an existing variable, then we don't need to redeclare the variable using let. Assignment. We need to reduce our hero's health as they take damage in the game. Before each console.log function in the provided code, change the value of player's health to be 100 less than it was before. I guess they haven't taught us how to do subtraction, so I'll just do it the simple way and say player health equal 900. Player health equal 800. And console.log. Player health equal 700. And here, player health equal 600. Have we learned comments yet? I don't know if we have, but we'll just gloss by over that for now. Correct? Okay. Sliding forward. Let's do some math. Now that we know how to store and change the value of variables, let's do some math. Here are some examples of common mathematical operators in JavaScript syntax. Let sum equal a plus b. Let difference equal a minus b. Let product equal a times b. Let quotient equal a divided by b. Assignment. Create a new variable called armored health on line 4 and set it equal to player health times armor multiplier. Okay, so new variable. That means we need to type let and then armored health equal player health times armor multiplier, and it's going to console.log that new number. Correct? Very good. Exercise 4 of Chapter 2. Let's do some more math. Creating negative numbers in JavaScript works the way you probably expect. Just add a minus sign in front of a number. Let my negative num equal -1. Assignment. When our hero walks through poison, their health should be reduced. Change the poison damage variable to be negative. Fun fact, computers can do math on really big numbers very quickly. Yeah, these are pretty big numbers. I will grant that. Okay, first I'll just run it, and then I'll look at what's happening. We have let player health equal 678, big number. Let poison damage equal minus 897, big number, not as big. Let player poison health equal player health but poison damage. Console.log player poison health. So we have the addition symbol, and we're doing this addition here. Okay. Chapter 2, Exercise 5. Comments. Comments don't run like code. They are ignored by the computer. Comments are useful for adding reminders or explaining what a piece of code does in plain English. There are two ways to add comments to code in JavaScript. Single-line comment. Speed is a variable describing how fast your player moves. Let speed equal 2. Multi-line comment. And to slow down a bit, we have this .. And those symbols say that it's a comment. Multi-line comment. /*. The armor value reduces the amount of damage is taken when a character gets hit by a bullet. Let armor equal 20. Single-line comments are best for 1 or 2 line explanations. Multi-line comments are best when you have a larger comment so that you don't need to type // over and over to start each line. Assignment. Line number 1 in the code was meant to be a comment, but the developer forgot to use the right syntax, //. Fix the bug by making the first line in the code a comment. The best sword variable holds the value of the best sword in the game. Bring this back. Oops. Let's put it right about here. Wait, why is it? Okay. So, // to make it a comment. Let best sword equal scimitar. Console.log best sword. Let's make sure it runs. Looks good. Okay, on to the next one. Chapter 2, Variables, Exercise 6. Variable names. Variable names can't have spaces, they're continuous strings of characters. In JavaScript, you should use camel case when creating variable names. Camel case is where the beginning of each new word, except the first, is capitalized so that it is easier to read. Such as, this is camel case, and some more camel case here. Casing examples. So this is showing us some other versions of how to do casing. No casing, it's some variable here, all lowercase, equal 10. Camel case, some variable here, with the V and the H capitalized. And snake case, with these cute little underscores. But again, we're focused on camel case for JavaScript. And then the exercise, what is valid camel case? Here it is with lowercase h and higher case h. Let's move quickly on to exercise 7, which is valid snake case. We have hero underscore health. And on to the next one. Okay, exercise 8, basic variable types. In JavaScript, there are several basic variable types. Number type. You're already familiar with the number type. Numbers aren't surrounded by quotes when created, but they can have decimals and negative signs. Let x equal 5, let x equal 5.2, let x equal -5. String type. Strings are raw text in coding speak. They are called strings because they are a list of characters strung together. Strings are declared in JavaScript by using single quotes, double quotes, or backticks. So some examples. Let name with single quotes equal quote boot.dev, end quote. Let name with double quotes equal double quote boot.dev, and let name with backticks equal backtick boot.dev. Another type is Boolean type. A Boolean is a type that can only have one of two values, true or false. As you may have heard, computers really only use ones and zeros. These ones and zeros are just Boolean values, with 0 corresponding to false and 1 corresponding to true. We can show an example of declaring let my bool equal true as a variable. Assignment: fix the bugs in the code to move on. Player health should be a number. Okay, player health should be a number. Have to take away those quotes. And player has magic should be a Boolean. Have to take away those quotes as well. So now, for our example exercise, we have let player health equal 100 and let player has magic equal true. And it says don't touch below this line. There, look, I'm touching it. No, I'm not. Not really. Okay, run. On to exercise 9. Undefined values. Not all variables have a value. We can declare an empty variable. Let empty. The value of empty in this instance is undefined until we use the assignment operator equal to give it a value. Undefined is not a specific string. Note that the undefined type is not the same as a string with a value of undefined. Let my undefined var, this is an undefined variable. Let my defined var equal undefined, this is a defined string. Oh, so this empty here could be anything. We could say like, let my var is empty. And that would also be an empty variable. Okay. Assignment. Declare an undefined variable named enemy. Don't change the console.log function. So let enemy, and this is an undefined, and the code I'm not supposed to touch is checking is enemy equal to undefined. I imagine the course will talk about this triple equal mark later. Okay. Forward and onward. Exercise 10. Dynamic typing. JavaScript is dynamically typed. All this means is that a variable can store any type, and that type can change. For example, if I make a number variable, I can later change that variable to be a string. This is valid. Let speed equal 5. Speed equal, quote, 5. However, just because you can doesn't mean you should. In almost all circumstances, it's a bad idea to change the type of a variable. The proper I just bumped my mic. Proper thing to do is to just create a new one. For example, let speed equal 5, let speed description equal 5. What if it weren't dynamically typed? Strongly typed languages like Go, which you'll learn in a later course, are strongly typed instead of dynamically typed. In a strongly typed language, if you tried to assign a value to a variable of the wrong type, an error would crash the program. If JavaScript were strongly typed, the first example from before, that's this one, would cause a crash on the second line because speed equals quote 5 on the second line, which is speed equal quote 5. The computer would give an error along the lines of, you can't assign a string value, quote 5 quote, to a number variable, speed. And the quiz item, is changing the type of a variable generally a good idea? Yes, no, or on Tuesdays? I really want to say on Tuesdays, but I'm going to play this straight and say no. Exercise 11. What kind of typing does JavaScript employ? From it says right over here, dynamic. Exercise 12 of Chapter 2. Math with strings. Most math operators we went over don't work with strings, but the exception is the plus addition operator. When working with strings, the plus operator performs a concatenation. Concatenation is a fancy word that means the joining of two strings. Let first name equal Lane. Let last name equal Wagner. Let full name equal first name plus last name. Full name now holds the value Lane Wagner. Notice the extra space at the end of Lane in the first name variable. That extra space is there to separate the words in the final result, Lane Wagner. Assignment. We have a second player in our game. We need to tell each of our players how much health they have left. 1. Edit line 7 to print player 1's health. You have 1200 health using string concatenation and the variables provided. Okay, so we have sentence start and sentence end. So we can take sentence start plus addition operator concatenation player 1 health plus addition operator for concatenation sentence end. And hopefully you get the pattern. So I can just copy paste to the second line using player 2 health. Edit line 8 to print player 2's health. You have 1100 health in the same way. Run code. You have 1200 health. You have 1100 health. Multivariable declaration, exercise 13. We can save space when creating many variables by declaring them on the same line. Let sword name equal Excalibur, sword damage equal 10, sword length equal 200. Any number of variables can be declared on the same line. Variables declared on the same line should be related to one another in some way so that the code remains easy to understand. We call code that's easy to understand clean code. How many variables can be declared on the same line? No limit. And on to exercise 14. What is clean code? Code that is easy for developers to read and understand, or code that runs quickly. Well, based on the opinion stated in the course here, it's easy to read and understand. Correct, good job. Okay, that's it for chapter 2.